question 9. So fx equal to 50x squared plus 38x plus 9 over 5x plus 2 squared times 1 minus 2x. And x cannot be negative 2/5 or half. Okay, given that fx can be expressed in the form a over 5x plus 2 plus b over 5x plus 2 squared plus c over 1 minus 2x, where a, b, c are constant. So part AI, find the values of b and values of c, and then show that a is equal to 0. Okay, so this is just a partial fraction question. So part A, we have 50x squared plus 38x plus 9 over 5x plus 2 squared times 1 minus 2x. And then that's equal to a over 5x plus 2, and then plus b over 5x plus 2 squared, and then plus c over 1 minus 2x. So if we want to compare them, we need to make sure the denominator be the same. So we need to make the denominator into this for the right-hand side. So the first one, we already have 5x plus 2. So we need another 5x plus 2 to make it 5x plus 2 squared, and also 1 minus 2x. So that would be a times by 5x plus 2 times by 1 minus 2x. And then for the second one, we already have 5x plus 2 squared, so we only need another 1 minus 2x to make the same denominator. And then for the last one, we already have 1 minus 2x, so we need another 5x plus 2 squared. So then they will have the same denominator, so the numerator should be the same. So to find out each value, we just have to substitute the values to cancel out some of the terms. So first, I was substituting x is equal to, so just let sum of the bracket is equal to 0. So for example, 1 minus 2x if it's equal to 0. So then 1 equal to 2x, so x just equal to 1/2. So we can let x equal to 1/2, or you can let 5x plus 2 equal to 0. So 5x equal to negative 2, x equal to negative 2 over 5. So both works. So let's just let x equal to 1/2 first. So if x is equal to 1/2, substitute to the left-hand side. So that would be 50 times by 1/2 squared plus 38 times 1/2 and then plus 9. So that would be 81 over 2. And then if we let x equal to 1/2, so this term will become 0, this term will become 0, so just the last one left. So 5 times by 1/2 and then plus 2 all square. So that would be 81 over 4 times by c. So c must be equal to 2. Okay, and then now we can substitute the other one. So x equal to negative 2 over 5. So if we substitute that in, so negative 2 over 5, so 50 times by negative 2 over 5 squared plus 38 times negative 2 over 5 plus 9. So that's just equal to 9 over 5 for the left-hand side, and then for the right-hand side. So if we substitute in negative 2 over 5, so this term will become 0 and last term will become 0, just the middle one left. Yeah. So then we can just do 1 minus 2 times by negative 2 over 5. So that would be just 9 over 5. So that would be 9 over 5b equal to 9 over 5. So b is equal to 1. So now we know the value of b and value of c. So to work out a, so a is the only value we don't know. So to work out a is very simple. You can let x equal to any value we want. So to make it easier, just let x equal to 0. So if x equal to 0, then we will have 9 left on the left-hand side. And then, so if x equal to 0, so it's just 2 left in this bracket and then 1 left in this bracket. So just 2a left. And then for the second bracket, we already know b is equal to 1. And if x equal to 0, so 1 times 1 is just 1. And then, so if x equal to 0, so 0 plus 2 just 2, 2 squared is 4. And then c is equal to 2, so just 2 times 4. So therefore, 9 is equal to 2a plus 2 times 4 is 8, plus 1 is 9. So then 2a is equal to 0. So a is equal to 0. So that's how we show that. Okay, part A is done. And then part B. So BI, use binomial expansions to show that in ascending powers of x, fx is equal to p plus qx plus rx squared, where p, q, r are simplified fractions to be found. And then we also need to find the range of values of x for which the expansion is valid. Okay, so just binomial expansion. And then we can use the partial fraction we did in part A. So therefore, fx is equal to a is equal to 0, so ignore the first term, and then b is equal to 1, so that would be 1 over 5x plus 2 squared. And then c is equal to 2, so that would be plus 2 over 1 minus 2x. And then that would be 5x plus 2 to the power negative 2, and then plus 2 times by 1 minus 2x, the power negative 1. And then to expand the first one, so remember the formula is 1 plus x apart n, and then modulus x has to be less than 1 for the value to be valid. Yeah. So we need to make it 1, not 2. So to rearrange that, we can factorize out 2 from the brackets. So that would be 2 and then 1 plus 5 over 2x. And then everything inside the bigger brackets apart negative 2. And then for the second one, it's already 1 for the first term, so it's fine. We don't need to do anything extra. So once we have this, we can apply the power to each one of them. So 2 to the power of negative 2 is just equal to 1/4. So that would be 1/4 times by 1 plus 5 over 2x, the power negative 2, plus 2 times by 1 minus 2x, the power negative 1. And then because they only want everything up to x squared term, so we don't need to expand like that much. We only need to get up to the x squared. So 1/4 stay the same, so apply the formula 1 plus nx. So n is negative 2, and then in this case, x is 5 over 2x. Yeah. And then plus n times by n minus 1, which is negative 3 over 2 factorial, times by 5 over 2x squared. And then for the next one, plus 2 times by, so 1 stay the same, plus negative 1 is n times by negative 2x, which is the x. And then plus n times by n minus 1, which is negative 2 over 2 factorial, times by negative 2x all squared. And then simplify each one. So we have 1/4, and then 1 minus 5x, because 2 times 5 over 2 become just 5, and it's negative, so negative 5x. And then for the next one, so just put in the calculator, negative 2 times by brackets, negative 3 over 2 factorial, and then times by, so just treat x as 1, so 5 over 2 squared, and then that'll be 75 over 4, and then x squared. So for the next one, it'll be 2, and then just make it clear. So 1 plus 2x, and then plus negative 1 times negative 2, it just become positive, and then 1 times 2 is just same as 2 factorial, so cancel out. Negative 2 squared is 4, so just 4x squared. So expand it out, so that'll be 1/4 minus 5 over 4x, and then plus 75 over 6 in x squared, and then plus 2 times 1 is 2, 2 times 2x is 4x, and 2 times 4x squared is 8x squared. So then 1/4 plus 2 is 9 over 4. And then negative 5 over 4x plus 4x is just equal to 11 over 4x. And then 75 over 16 plus 8, which is 203 over 16x squared. So that will be the final answer for part I. And then for the range of values of x for which the expansion is valid, so we'll only look at, because this modulus x less than 1, is this x is the formula 1 plus x part n that x, yeah. So we need to look at the form we simplified, which is this one, 1 plus 5 over 2x, and then 1 minus 2x. So it's 5 over 2x and negative 2x, what we need. So to find the range of values, we just let 5 over 2x modulus less than 1. So, and then also negative 2x modulus less than 1. So then this one we just modulus 5 over 2 times modulus x less than 1. So modulus x is less than 2 over 5. And then for the other one, it just become 2 modulus x is less than 1. So modulus x is less than 1 over 2. So we're looking for values which satisfy all of them. Yeah, not just it only works for one but doesn't work for the other. So therefore, we need the one satisfy both. So we need to pick the smallest one. Yeah. And then clearly 2 over 5 is smaller than 1 over 2. So this will be the actual answer. Yeah. So the range of values of x for which the expansion is valid, just modulus x is less than 2 over 5. So that will be the final answer to this question.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.